Hi, in this video I'm going to cover the basics of the inverse trigonometric functions. Now you know the basic trig functions. They take one of the non-right angles theta of a right triangle as an input, and they spit out the ratio of sides as an output. And our trig functions are down here. Sine of theta is equal to opposite over hypotenuse. Cos of theta is adjacent over hypotenuse. And tan of theta is opposite over adjacent. Those are the opposite over adjacent sides. Because our trig functions are functions, they work one way. They take an angle as an input and spit out the sides as an output, which means we need to know the angle if we want to find the sides. But what happens if we want to find the angle? Well, we know that inverse functions are functions which reverse the outputs and the inputs. So we're going to use the inverse trig functions to find angles in given right triangles. So for an inverse trig function, the ratio of two sides is going to be our input, and the angle theta is going to be our output. So let's take a look at what this means on this triangle down here. On this triangle, I've chosen my top right angle to be theta. So based on my trig functions, the adjacent leg is right here. I'll label that A. The opposite leg is down here. That's going to be O. And the hypotenuse is over here. The trig functions in blue up here still hold. They're still valid. But if, for example, we know O and H, and we want to solve for theta, then we'll use our inverse trig function, which is going to be the inverse tangent function, which I can write as tan to the minus 1 of, we reverse our outputs and inputs, O over A is equal to theta. That is if we know the opposite leg and the adjacent leg to our angle theta. I may have misspoken earlier. If we know the adjacent leg and the hypotenuse, we're going to use inverse cosine, which is going to be cos to the minus 1, or inverse cos of A over H is equal to theta. And if we know O and H, we can solve for theta using inverse sine. Inverse sine of O over H is equal to theta. Now these inverse trig functions are sometimes written with this -1 power, but this -1 superscript. That is not a power. So sometimes these trig functions are also written or spoken as, this can be arc sine, this is arc cos, and this is arc tan. That's just so it's not confusing. But on your calculator, when you're calculating an inverse trig function, it's going to be that, it's going to look like a -1 in the superscript for the inverse function. So let's scroll down here, and here's our example. We have a right triangle, and two of the sides are given. We want to find the two unknown angles, find theta and phi. Now we have two sides. We could use the Pythagorean theorem to find the third side, but eventually we're going to have to use our inverse trig functions to solve. So let's start by looking at theta. Find our angle theta. Now based on theta, if we choose theta as our base angle, then theta is our unknown. We know 36 kilometers is the opposite leg. O equals 36 kilometers. And we know that 80 kilometers is the hypotenuse. H equals 80 kilometers. So if we set up our regular trig function, opposite and hypotenuse, so katoa, that's going to be a sine function. We would write it as sine of theta is equal to O over H. However, that doesn't let us solve for theta. We need to use the inverse function, which will switch our inputs and outputs. We get inverse sine of O over H is equal to theta. Then we just plug in our numbers. It's going to be inverse sine of O is equal to 36 kilometers divided by 80 kilometers. Kilometers cancel. We plug that into our calculator, and since we want our angle in degrees, let's make sure our calculator is in degree mode. On most TI calculators, to get to the inverse trig functions, you hit second, and then you go to the regular trig function. So I'm doing inverse sine of 36 over 80 gives me 26.7 degrees. 26.7 degrees. And that's our angle theta. Okay, so we know theta is equal to 26.7 degrees. We could just use the fact that the total internal angles of a right triangle add up to 180 to find phi. And that's the easiest way to do it, but I'm going to do one more example of using an inverse trig function to find phi. So let's find phi over here. I'm going to go back to blue. In this case, phi is our base angle, so that's going to be phi is our unknown. In this case, 36 kilometers is our adjacent leg, and our hypotenuse is 80 kilometers. So the trig function that we use that relates adjacent to hypotenuse, so ka toa, is going to be cosine. Since we know we want the angle as our output, we're going to use the inverse cosine. Cos to the minus 1. That is inverse cosine, not cos to the minus 1 power. Inverse cos of adjacent over hypotenuse is equal to phi in this case. So we do inverse cos of the adjacent leg is 36 kilometers divided by 80 kilometers. Our units cancel. We plug it into our... We get 63.3 degrees. 63.3 degrees. So our angle phi is equal to 63.3 degrees. And that's how we use our inverse trig functions. Our inverse trig functions just reverse the inputs and outputs, so they allow us to find the angle in a right triangle if we know at least two of the sides. Remember, the trig functions are the same, so you can still use SOHCAHTOA to figure out which is which. Hope that was helpful. Bye.